All right, so now we're just going to use some given graphs and given functions, and I call them limit laws. Sometimes they're limit properties. So we've done these limit properties algebraically with functions. We just haven't done them with a graph, but the idea is the same. I'll show you the long way, the first one, but you don't need to prove this at all, okay? It's just understood that you'll know how to evaluate these problems. So on number one, when you're given a limit of f plus g, due to the properties, what you're algebraically allowed to do is apply the limit, we don't call it distributing, of x approaches 0 of f of x plus the limit as x approaches 0 of g of x. It looks like distribution, but it really is applying the property. So what we want to do is we want to use each curve, because the left curve is f, the right curve is g, to evaluate the limit. So as we approach 0 of f, remember 0 is my target, and I want to look at the y value because that's the limit. That y value is 1. So that entire limit is 1. And this is what you'll just show the math when you're justifying your worksheet, because I give you the answers and it says, hey, help me justify this. The limit as x approaches 0 of g, so you go to the g graph and you go to 0 and it says, oh yeah, well its y value is also 0. So this works with a given graph or a table of values, okay? And so you have 1 plus 0, and so you say the entire limit is equal to 1. The same thing applies to multiplication. So the limit as x approaches 1 of f, so you go to 1, and we want the limit value, so we get 2, times g, the limit as x approaches 1, its y value happens to be 1 as well. And so the entire limit is 2. So that's the theory behind it. You don't really write that out every single time. It's understood, you know how the properties work. So let's do the last one. I'm trying to get everything on the same screen. The limit as x approaches 1, we just did f, so we said that's equal to 2 plus 1 equals 3. Okay. And then the last one, I'm going to have to scroll. So remember, this is 2 from above. So we've got 2 times, and I need to scroll up to f. So 2 from above of f. Well, the whole limit we're looking at as x approaches 2 is defined at 2 anyway. So it's going to be the y value. So we get 1. Plus 3 times the limit as x approaches 2 of g. So this is why they really used it. So 2 from above, we're going to approach this way. As we get to 2, the y value is approaching 3. On one function, you might think, that's kind of weird. Why'd they do that? And then it might become obvious on the next function. So 2 plus 9 is 11. And then we've got this. So we get 2 from below of x squared. So that really just means to plug in 2. We're not using a function there. So we're going to get 4 plus the natural log. Once again, you plug in 2. And we just leave this as natural log. We don't use the decimal. Times g of x. So I need to do 2 from below of g. So we'll go back to our graph. 2 from below, well, that's also approaching the y value of 2. Now, this 2 is not inside the log, so we're not allowed to say that that's 4. What we can do, though, is if I rewrote this, 4 plus 2, put the 2 in front, and then not exponent properties, log exponent property says we can put that 2 up top. Do you have to? No, not if this isn't multiple choice. So you would get 4 plus the natural log of 4, because that would be 2 squared. We don't write the decimal for that, okay? That's good enough. All right, the limit as x approaches 2 of f minus g. So if I go to 2 on f, well, 2 on f is 1. Then if I go to 2 on G, well, this is where it's tricky. So if we go to 2, it doesn't have one limit value because it's broken. So this, too far, does not exist. You can't pick both, and you can't just pick one. Well, since one part of this doesn't exist, the entire thing does not exist. Okay. All right, let's try another one. So we've got, I'm going to make this smaller. I know you have the worksheet. We've got limit as x approaches 3 of g divided by f. So once again, you can apply these limits separately. So if we go to 3 of g, we get 0. And if we go to 3 on f, we get negative 2. And 0 can be on top. That's a great answer, 0. 3 from above. So 3 from above, well, it's going to be the same as 3 below and 3 because we're going from above. So that is negative 2. And 3 from above, same thing. There was no need to use this notation on this problem. I think they're trying to trick you. Well, it's still 0. You can't divide by 0, so this does not exist. If you wrote undefined, that's fine too. You just won't see both options. Okay, so I'm just going to put it in parentheses, undefined. Okay, that's the reason why it does not exist. I like to put that in case multiple choice options are different. You just never know. Then we kind of just talked about it on number 8. This 3 from above, it would have made sense if it was 2 from above. They picked 3. So since 3 is not where it's broken, that's going to be the same answer as number 8 was. Okay? So negative 2 over 0, same answer. Okay. And our last one. So this one, well, we've got a square root. It's going to stay 1. And then f of, I want to approach 1. So if I look at f as we approach 1, its y value is 2. Limit y value, sorry, not the actual y value. And then we're going to do it for g. So our limit on g as x equals 1 is 1. So we get root 4, which is 2. All right, and our last one, negative 1. So our limit of f at negative 1, well, we don't match up, so we don't have a limit on f. So since f does not exist, the entire problem does not exist. Okay. So go ahead and give those a try and see how you do.